Hey everyone, happy Friday. Hopefully everything's going okay for everyone. Hopefully you had a good Thursday. I'm sure you've heard already that we will not be together again in a classroom for the rest of this year. Governor Walz just came out yesterday and said that that was going to be the case. So here we are. We're going to be continuing to learn like this for the rest of the semester. So as it's always been, if you have questions or comments, certainly get in touch with me. Some of you have certainly been doing that. Others I have not heard so much from, so I assume that everything is going okay. Um, what we're going to be doing today is more with cones. We'll finish up cones today, and then next week, all we have left to do is spheres. We'll probably do spheres on Monday, and there won't be any spheres backwards because spheres, even though the formula is going to look a little complicated, it's actually easier because there's only one input and one output. So those will be much, much less complicated types of problems. But for what we're doing today, it cones backwards. Instead of me telling you what the radius and the height is and you having to figure out surface area and volume, I'll tell you the surface area or volume or something like that. And you'll have to work backwards and figure out some of the dimensions. But the formulas we're going to use are the same. These are the same formulas that you use for all cones. Lateral area is technically the perimeter of the base times the height divided by 2, but because there's a 2 in the formula for the circumference, it ends up canceling out and giving us just this formula. Surface area is the lateral area plus the area of the base, the lateral area plus the area of a circle, and then finally the volume of a cone is 1/3 of the volume of the corresponding cylinder. So hopefully these formulas look familiar to you. Hopefully you're getting these written down to have all in one place for the test next week. So I've got just a few problems to go through with you. They'll feel pretty similar to what we've been doing. First one I have is given the volume of this cone is 12 pi cubic centimeters, and I want to find the exact surface area. So working backwards from the volume, which means we go to the volume formula. Volume is pi r squared times the height divided by 3. And so in this formula, we know that the volume is 12 pi because we were given that. In the diagram, we can see that the height of the cone is 4. So I plug in 12 pi, I plug in 4, and then we get to work doing a little bit of algebra. In this case, pi divided by pi cancels out. So it's gone from both sides. And then I multiply both sides by 3 because I want to get rid of the fraction. So 3 divided by 3 cancels out. 3 times 12 gives me 36. And then all I have left is 36 equals 4 times the radius squared. So I divide by 4 and get 9 is equal to the radius squared. And if something squared is 9, then the radius must be 3. So that gives us the radius of the cone. And then we're going to do this for every problem we do today. Oh, I take that back. I think one maybe we won't. But for most problems at this point, when I've got this right triangle, I've got one leg down here, the radius, I've got one leg up here, the height of the cone. And in order to find the surface area that we're trying to find, we're going to need the slant height. That's the only thing that I don't know in the formula. I've got the radius, but the slant height is unknown. So we go to the Pythagorean theorem and say a squared plus b squared equals c squared. In this case, 3 is the radius. That could be our a in the formula. 4 is the height. That can be our b. And then the hypotenuse is the slant height. And so 3 squared plus 4 squared equals the slant height squared. 3 squared plus 4 squared is 25. And if the slant height squared is 25, then the slant height must be 5. And now I've got everything that I need in the formula for surface area, so I plug it in. The radius was 3, the slant height was 5. 3 times 5 is 15. 3 squared is 9. 15 pi plus 9 pi is 24 pi. And in this case, since I said the exact surface area, the answer I'd be looking for would be that one. If you want the approximation, that's about 75.4, but because this question asked for the exact surface area, that would be the answer that I would be looking for. So there we go. Working backwards from volume to find surface area. Next problem we're going to take a look at Given the surface area, let's work our way backwards and find the slant height. So, like I always recommend that you do for these problems, use the formula. We're given the surface area, so let's use the surface area formula that says surface area is pi times radius times slant height plus pi r squared. And let's see what we know. Surface area was given. On the diagram, we see that the radius is 10, so I plugged that information in. And then the only thing that I don't know is the slant height. And so if we only have one unknown, that means this is an algebra problem. This one didn't say to give an exact value, so I'm just going to go ahead and multiply these out. 10 times pi is 31.4. 100 times pi is 314.2. I rounded it off. And then a little bit of algebra. I subtracted 314 from both sides. And when I subtract 314.2 from 492.5, I get 628.3. And so 628.3 is equal to 31.4 times the slant height. Divide both sides by the 31.4 because I want to get the slant height all by itself. And when I divide 31.4 divided by 31.4, we get the slant height is 20. Since this problem was given in inches, my slant height is 20. And if I wanted to at this point, since I have the slant height, I've got the radius, I could use the Pythagorean theorem and find the height, and then I could use that to find the volume. But they didn't ask me to do that on this problem, so I guess I'm not going to bother with that. But that's the working backwards part. Given the slant height, plug in information to the formula, and then do some algebra to solve for what we do not know, in this case, the slant height. All right, and then one more problem for us to take a look at today. Given the lateral area is 204.2 cubic centimeters, find the surface area and volume. And in this case, I've been given the slant height of 13. So where do we start on this one? Start with what we know. The lateral area is 204.2. So let's use that formula. The lateral area of a cone is pi times the radius times the slant height. Let's see what we know. I've got the lateral area. I can plug that in. Slant height given on the diagram is 13, so I plug that in. And then in this formula, I've got everything I need except for the radius. So I can solve for the radius by doing a little bit of algebra. Similar to the previous problem, it didn't say find the exact value, so I'm going to go ahead and multiply this out. 13 times pi, I plugged in my calculator, I got about 40.84, and then I divided both sides by that. Divide both sides by 40.84, and I got the radius is equal to 5. Just doing algebra. Once you've got the radius equal to 5, here we go again, Pythagorean theorem. The hypotenuse is 13. One of the legs is 5. A squared plus B squared equals C squared. In this case, 5 squared plus H squared equals 13 squared. I called H the height. And then plug them in the formula. 5 squared is 25. 13 squared is 169. Subtract 25 from both sides of the equation. And I get H squared equals 144. The square root of 144 is 12. And so the height of this cone must be 12. So now I've got that. I've got the radius of 5 that I figured out 2 slides ago. And so if I want the surface area and volume, I've got everything that I need. Height, radius, slant height. And so now this problem becomes the problems that you hopefully did on the previous homework assignment, hopefully did this one yesterday. Surface area is pi times radius times slant height. Radius is 5. Slant height is 13 that we figured out with the Pythagorean theorem. Nope, I take it back. We were given that. We didn't need to figure that one out. But the radius, we had to use formulas to find that. Anyway, we plug everything in. 5 times 13 is 65. 5 squared is 25. I put these together and said 65 pi plus 25 pi is 90 pi. I suppose you could plug this in your calculator right here. I chose to keep it in exact form for a little while, but then we can plug it into our calculator. I would actually accept either one of these as a perfectly correct answer. If you give something to me in exact form, I like that even more than the approximate. But this one didn't ask for the exact value, So 282.74 square centimeters is the surface area. And then finally, the volume formula says volume is pi r squared, area of the base times the height. Whoops, divided by 3. I forgot to do that. Volume is pi r squared times height divided by 3. Plug in 5 for the radius, plug in 12 for the height, divided by 3. 5 squared times 12 is 300. I forgot to divide by 3. And so I'll have to take everything and divide by 3. And then 942.5 divided by 3, I hope it's 314 point, about 1/6, I believe that's going to be. I'm going to double check that on my calculator after I get this written down. But I think that should be correct. Let's see, where's my calculator? 942.5 divided by 3. Yep, looks like we're in good shape. So that is how we find the volume, surface area, lateral area, given volume, surface area, or lateral area. Get those formulas. If you don't have those formulas written down, I'm going to go back to that slide so you can get them. Give you one last chance to get them written down. But of course, this is a video, so you could pause, you could go back, you can rewatch this stuff if you're having trouble with homework assignments. Um, Everything on the homework assignment should be represented in this lesson in some way or another, but these are the main formulas. Plug in what you know, solve for what you don't. And that's all we got. So I hope you guys have a great day. I hope you have a good weekend. I hope the weather's okay for us to get outside a little bit. And stay safe, and we'll see you next week. Bye-bye.